For the next few moments, you'll have to come up to me to ask, but otherwise, 10 minutes remaining. How we doing? There are a couple of tricky ones on here that if you aren't actually paying attention, you're going to be like, ugh. Please don't be like, ugh. Please be like, oh yeah, you're not fooling me. Because remember, of course, can anything squared equal a negative? That wasn't a rhetorical question, but we'll just assume that it was.
I don't know what to first thing we do.
I just took a whole lap. Nobody stopped me. Everybody knows what they're doing? Spectacular. I will take attendance in a moment because I'm going to help Yashin first.
It's 2. What do you mean? You add another 2.
When are you going to get glasses? There's nothing wrong with them. You can still be stunningly handsome wearing glasses. Shut it! I only say this, Emma, because when you get in the habit of what you're doing, even when you get glasses and you can see fine, you will still go, I still do it. And I can see fine. I actually have better than 20/20 vision with these glasses. And still, I do it. All right, there is number 1 and 2. Why is this no solution? Can anything squared ever equal a negative number? No, because when you square anything, what do you get? A positive number. Negative x squared is positive. You cannot have this. Now, what does this mean? I'm going to bring your attention to this again. Soon as I see that x squared, I know that this is going to make a U-shaped line, yes? A parabola. This says when x is 4 or x is 0, this x is 4 or x is 2, I'm going to have a result of 0, yes? Which means the line will go through 4 and 2. It'll look like that. These are the x values. So in this one, if there's no solution, what does that mean the line would look like? What on this construction here will that u not touch? It will not touch the x-axis, right? Because there is no x values that work. Everybody understand? This is where we're getting to. We're building up to this. There's the second 2. Check your work over. Make sure you're doing it right. That happens a lot. People forget that it's plus or minus. Now, could you tidy this up? Technically, because it's got a root 2 on the bottom, technically we should rationalize that denominator and work it all out, right? What? How do you get what? Well, when you move the 5 over, it becomes negative 5, right? Right? Then, when you complete the square here, you added negative 2 plus 1 is negative 2 times positive 1 is negative 2, right? So you took away 7 more, or 2 more to get to negative 7. You with me so far? Then, I had this 2 out front here, yeah? That I had to get rid of. So I divided this by 2. Then I had to divide that by 2. Okay? Again, I remind you all, it's not difficult, but it's very complicated, yes? There's a million things going on, and you got to be careful. And here again, we had a negative number, so we had no solution. Excuse me. And the last two, this one is finished off. I finished, took it one step further, but there's no need to. Pardon me? Oh, I don't think we even need to mark it. I called it an assignment, but I think I'm happy with people just getting her done. Are we okay? All right, everybody take a 1 minute break. I won't speak for 1 minute. Stretch, relax. Then we'll go on. All righty. If everyone could turn to page 80. Those three are all quadratic equations, yes? How do you know they're quadratic equations? What is the thing there that tells you they are quadratic equations, which means they have two answers? Pardon me? It equals 0? Not quite. X plus 7 equals 0 is not a quadratic equation. It only has one answer. What is it about those three equations that make us know that they are quadratic and that they have two answers? Sarah? X squared. Because the input is squared, there can be two answers, right? Because a square root has two answers. Everybody cool? Now, that first one you can solve in about 2 seconds, can't you? Why? What is it about the first one that makes it super easy to solve? It's factor, right? Factor it in 2 seconds. X plus 3, X plus 4 equals 0, X equals -3, -4. Super easy, right? Why is the second one slightly more difficult? It doesn't factor, so you got to complete the square, right? But again, pretty easy. X squared plus 6x, oh, sorry, this should have been minus 14 equals 14. X squared plus 6x plus 9 equals 23. X plus 3 squared equals 23. X plus 3 equals plus or minus root 23. And x equals -3 plus or minus the root of 23. No problem, right? Obviously, it might take you guys a little bit longer, or you might have to write out one more step, but no problem, yes? What about the third one? Why is that one easy? It's got a number out in front. Yuck, barf, we're bad at that. But you could GCF it, and then you'd end up back at here, right? Everybody cool? Right? What about this one? Is that one fairly easy to solve? It doesn't GCF, but does it factor? It factors, right? 2 times 3 is 6. Factors of 6 that add to 5 or 2 and 3. You could factor that, yeah? So as long as we can factor or complete the square, we're in pretty good shape, right? Right? How many numbers are there? There's an infinite amount of numbers, right? Which means there's an infinite amount of quadratic equations, yes? Because there's an infinite amount of quadratic equations, there are going to be some that we cannot factor, and that completing the square is barfully difficult. Okay? Let me show you one. Let's go 3x squared plus 17x minus 1 equals 0. Does that factor? No, of course not. Complete the square. Well, if I complete the square, I've either got to divide out that 3, but that doesn't work because it doesn't divide out of 17, right? Even if I divided that 3 out of 17, I would have x squared plus 17 thirds x. And then if I want to complete that square, I need to do half of 17 thirds and then square it. Pain in the ass, right? So, sometimes we get ones that nothing works. But of course it's math. So are we ever at a point where we can do nothing? Very, very rarely. And this, we can do something. Now remember, this is a quadratic equation in general form, which is ax squared plus bx plus c equals 0. Now some of you say, but Mr. Myers, it's a negative right there. Negative is just adding, or subtraction is just adding a negative, right? We're all cool with that? So this is what every quadratic looks like, right? Sometimes there's no a value, but there is an a value, because what's the a value here? 1. Everybody good? Okay. So we all understand we're here, yes? And what is our goal always? Solve for x, correct? So if I have something that's barfy and ugly, like 3x squared plus 17x minus 1, if we can solve for x, we'll be in business, right? Okay. Now, if this is the general form of a quadratic equation, meaning every quadratic equation looks like this, then if we can solve for x on the blue line here, then we must have a way to solve every single quadratic equation. Do you follow me? Let's do so. I need to solve for x. So we are going to write it out over here. Ax squared plus bx plus c equals 0. And let's do so. How do I solve for x? What would be the first thing you guys would do to get x by itself in this equation? What's the first thing you would do? You could subtract c. All right. Pardon me. What did you say, Sarah? You could divide by a. Both of which will work. Yes. Which one do you want to do first? Nobody cares. Well, if I add numbers here, we would divide by 2, right? So let's do the divide by a. No offense, Jack, but your way works too. So let's divide everything by a. Now I've got x squared equals b over, oh, not equals, idiot head, plus b over a x plus c over a equals 0. Are we happy? Are we happy? Now, Jack, how could I get x isolated now?
Subtract c over a.
Right. So the next, if I move these, I'm going to get x squared equals negative b over a x minus c over a. Right? Right? Are we happy? Now, what would I do next? I could square root everything, plus or minus the square root of negative b over ax minus c over a. Everybody happy there? Yeah? Now what would you do? Or are we happy? Are we happy with that? Okay. I'm a little bit sad that we're happy with that. Pardon me? I want to bring us back to here. Jack's first move was just to move C, yes? Now look at that. Does that look like something we've seen? Does that look like something we've seen? It does, doesn't it? What would be a better move there? To complete the square, right? So if I complete the square, what's half of B over A squared? B over A times a half is B over 2A, yes? And then square it. What do we get? B squared over 4A squared, right? Everybody happy? So plus B squared over 4A squared, which means what do I got to add to this side? Negative C over A plus B over 4A squared, yes? Everyone agree? Now, this factors now, right? A plus what? Agreed? What has to happen here? What's wrong with that? It's not a common denominator. Can we make it a common denominator? What would I have to multiply that by to get that? 4A. So what do I got to multiply that by? 4A. So negative 4AC plus B. Plus B squared, yeah. Everybody cool? Now what would we do? Square root both sides. Plus or minus the root of negative 4AC plus B squared over 4A squared. Then what? What moves? When we complete the square, what would we move here? This, right? Negative B over 2A plus or minus the root of 4AC plus B squared, negative 4AC plus B squared over the root of 4A squared, right? What's the root of 4A squared? Negative B plus or minus the root of, this is going to be over 2A. This, we just like to reverse the order because we like to put we don't like a negative at the front, right? So it's going to be B squared minus 4AC. Now please notice, X equals all that. What was our goal up here? I know the screen's blue. What was our goal up here? solve for x. Now we have x equals all this. Now, this is why it works. This is what you do. What do you see right there? B. What do you see right there? B. What do you see right there? C. What do you see right there? C. What do you see right there? What do you see right there and there? So if I take those numbers, A, B, C, and I put them in there, what will I get? X. And this works every single time. If you can factor it, if you complete the square, or if you can't do either of them. Which is why kids from other countries often use this right away. Now, please notice how much substituting you have to do here, right? And how many positives and negatives there are in here. Is it possible that you will bring down something poorly? Yes. That's why I only use this when I have to. If I can factor it or I can complete the square easily, I always do one of those two. But that isn't going to cover the vast majority of the quadratic equations, is it? So we have this for the rest of them. There it is right there. We've shown how it works. Now, let's look at this one. Does that factor? No, it doesn't. But it would be easy to complete the square, right? Because that 4 is even. We could complete the square easily here. We've practiced that a lot, so we're going to use the quadratic formula this time. So what is that? That's A. So A equals what? 1. What does B equal? 4. And what does C equal? -6. And then all we do is plug it into the equation. X equals -b plus or minus the square root of b squared minus 4ac over 2a. So, what goes in for b? -4, because it's negative b, right? Plus or minus the root of 4 squared minus 4 times what? 1 times what? -6. All over what? 2 times 1. Now, can we work in our head if we can? We can do these in our heads because it's all numbers, yeah? So -4 plus or minus, what is 4 squared? 16. What's -4 times 1 times -6? Positive 24, right? Over 2. -4 plus or minus the root of what's 16 plus 24? 40 over 2. And what's our last step? Simplify. -4 plus or minus 2 root 10 over 2. And our last step? What do I do? Simplify those. -2 plus or minus root 10. Exact answer or approximate answer? Exact answer. Math class answer. Physics class answer? No. What is the root of 10? It's a little bit more than 3, right? So if we got out our calculator, it would be like 3.1, yeah? So it would be -2 plus 3.1 or -2 minus 3.1. Everybody good? All right. What's different about B? The 7 needs to do what, Isabel? Needs to go to the other side. So we have a C, right? That doesn't factor. 2 times 7 is 14. There's no factors of 14 that add to 3. Okay, I'm going to complete the square. Oh, barf, I don't want to complete the square. Why? What about that makes completing the square barfy? 3 doesn't divide by 2 easily, does it? So if I can't factor and we can't complete the square, we should go to the quadratic formula, right? Let's do so. What does A equal? What does B equal? -3. What does C equal? -7. Start filling it in. X equals, what is -B? 3. Good. Plus or minus the root of -3 squared minus 4 times 2 times -7. All that over 2 times 2. And then just simplify. What's this one going to be? This one always screws kids up. What's that going to be? What's -4 times 2 times -7? He waited patiently for grade 11s to multiply 3 numbers. He listened for the click, click, click of calculator keys to multiply 4 times 2 times 7. 56. Three plus or minus the root of 3 plus or minus the root of 65 over 4. Does 65 simplify? No, because it's 5 times 13. So are we done? Math class answer or physics class answer? Math class answer. What approximately is the physics class answer? What is that approximately? 8. So it is approximately 3 plus 8, which is 11 over 4, or 3 minus 8, which is -5 over 4. Approximately X. Everybody good? You guys do the third one. Go. Everybody good, right? All right. Now, listen closely, please. We're going to do 81 together. The top of it. This, start writing this down, please, because tomorrow is cumulative day. This is homework. This is homework. Be very careful with 9 and 10. And that's going to be, no, you know what? I want you to try these. When will all of that be due? Thursday, because tomorrow's cumulative day. All right? So let's work on this one together. Is this a real life problem or a math class problem? Math class problem, because you don't care about the sums of squares of numbers, do you? Not in the real world. You don't care about that stuff. But can the skills of working with those numbers apply to real life problems? Of course they can. So, what do I know in this question? Do I know the two numbers?
No.
No. So the first number, number 1, is what value? X. What is value of number 2? No. No. They are consecutive integers. What is the next number? X? No. X plus 1. Why can I not make it y? Because that's a different value, right? And then I'm trying to solve for 2 variables. So, what else do I know? The sum of the squares. I know that n1 squared plus n2 squared equals what? 613. What is n1? X squared. What is n2? X plus 1 squared equals 613. And now we could solve that, couldn't we? X squared plus 2x plus 1 equals 613. What's x squared plus x squared? 2x squared plus 2x plus 1 equals 613. Does that factor? Doesn't factor, does it? And even if it did factor, would you really want to factor 600, bring 613 over here and then factor that mess? No. You could complete the square, kind of, right? Except once you factor out that 2, this is going to be 1, isn't it? And do we like fractions? No. So what is our best choice here? Quadratic formula. Do we have an ABC? What is A? 2. What is B? What is C? Look closer. What? Negative 600 and? Oh, you were smoldering there, Noah. Not quite on fire, but yeah. You got to bring this over, don't you? Then it becomes negative 613. So C is negative 612. Now, hey, big stuff. No such thing as climate change.
No?
Nope.
Sure. Whatever. You got time?
Time right now to talk to you.
No.
Oh, to do your thing.
Yeah.
Yeah, go ahead. Because you guys know what to do here now, don't you? Now, are we going to be able to do this one in our heads? C's a pretty big number, isn't it? So we're going to need to break out our calculator anyway. Everybody cool? Mr. K is going to hand something out. While he's handing out, we're going to talk about this, right? Is there a way I can make this slightly easier to deal with? I could divide by 2, which would give me what? x squared plus x minus 306. So what would happen to all these numbers? 1, 1, and negative 306. Now take that and run it through the quadratic formula.
Kept asking for it.
Thanks.
That's not right. It's not $12.99. Stupid working in your head.
It was a decent show, right?
$12.24. What?
That was a decent show.
Yeah, it was. It was fun. $12.25, which is 35.
Congratulations. Off you go.
So if x is 17, what is my first number? 17. What's my second number? No. X equals these two. So either x is 17 and 18, or x equals negative 18 and x plus 1 equals negative 17. Everybody cool? All right, listen to Mr. K. And you have 8. 1, 2, 3, 4. Apparently you only have 8 questions, 9, 10, 11 for homework. But that homework's not due until when? Thursday, because what's tomorrow? Cumulative covering what? Exponents, radicals, polynomial multiplication, factoring, and that's it.